Good morning. I think all of you are doing well. Circle, different forms. I've explained last video those three forms of circle. One is standard equation of circle. The other one is diameter form of circle. Then general equation of a circle. Today's class we will find application of those three formula to solve problems from circle, and we'll find some more cases where these equations, more complicated cases better to say, these equations can be used to get the equation of circle quickly. Without wasting time, let us remember the standard equation of circle. If the center of circle is at 0, 0 and radius is a, we have seen the equation of circle is x square plus y square equal to a square. This is just little bit recapitulation of the topic we have already done. But center may not be 0, 0 always. If the center is at hk, center is not at origin, but radius remains a only, then equation of circle diagram will be shifted to that point where 0, 0 hk will be replaced, hk will replace 0, 0, and this is transformation of circle. It will go to this point. Center was there, now center is moved to this point. Equation becomes x minus h whole square plus y minus k whole square equal to a square. All these we have derived. We have seen simple application of it. Then next one, the diameter form of a circle. If two extremities of circle given, then instead of using this equation, we can use this equation to get the equation of circle quickly. But what I can tell you, circle is circle. Whatever form you are getting here, the same equation, same form you will be getting after simplification of this diametric form of circle also, where extremities of diameter are given. And then you have seen the general equation of circle, where the equation is x square plus y square plus 2gx plus 2fy plus c equal to 0, with center minus g minus f and radius under root g square plus f square minus c. This we have proved also. Now, just by looking at the equation and finding g, f and c, also finding under root g square plus f square minus c, we can quickly decide whether the circle is possible or not. All equations of this form will not give you circle. It will give you circle under what condition? When the radius thing is this expression inside root is a positive quantity. It will give you a circle, a real circle, if under root this thing, root over g square plus f square minus c greater than 0, it will give you a real circle. If it is less than 0, it will represent a virtual circle. Why virtual circle? Why it is so named? Why we are calling it virtual circle? Because we have seen that this equation x square plus y square plus 2gx plus 2fy plus c equal to 0 represent a circle whose center is at minus g minus f and radius root over g square plus f square minus c. So one can claim just by seeing equation of this form that center has to be minus g minus f, radius has to be this, without thinking whether this situation always will arise or not. Because under root g square plus f square minus c, this expression, if it is negative, then it is not possible to get a circle. But this is general equation of circle. So based on this, we can say that if the thing inside root is becoming negative, then it will represent a virtual circle. And if it is equal to 0, then circle radius doesn't exist. It will represent a point circle. This is just little bit discussion of different forms of circle. and just by looking at the equation in general form, we can decide quickly whether it will represent a circle or not. It may not represent circle always. All this we have seen in the previous class. Now we are going to discuss some problem oriented discussion. Problem solving approach is required to solve sums from circle. We'll remember some special cases where circles may be concentric. This term may arise. What do you mean by concentric circle? Concentric circles means two circles or more circles, they have the same center. You can see that there is one circle whose radius is R1. Another circle is there whose radius is R2. This one might have radius 3 unit. This one might have radius 7 unit. They are concentric circle because they have the same center. Now what is common between these two circles? If you refer this one as circle C1 and this one as circle C2, what is common between them? The quantity which is common between them is the center. Center is h, k. So by taking center at h, k and by taking point Pxy on the outer circle, equation can be stated. It is going to be x minus h whole square, y minus k whole square equal to r1 square. And inner circle, if you want to describe, same HQ will be there, just radius would be R1 or R2. If you have taken this one R1, you take this radius R2, then equation of this circle, inner one, C1 will be x minus, C1 equation will be x minus h whole square, y minus k whole square equal to R2 square. Okay, so this is the concept of concentric circle. Two circles have the same center, their radii will differ. And another term you need to know regarding circles, those points given may be concyclic point. Under what condition? 4 points P, Q, R, S will be concyclic. Concyclic means those 4 points will be lying on the same circle. You know, through 3 points, one and only one circle can be drawn. If the 4th point lies on the same circle, if it satisfies the equation of the circle passing through 3 given points, then those 4 points are going to be concyclic. So for concyclic points, you just remember that those 4 points will be lying on the same circle. Now, let me discuss few more cases where if you know before solving problems on circles, it will be easier for you to tackle sums from circle. Situation may arise this manner. A circle touching x-axis. You might have seen this kind of problem. Without any good idea, you are able to solve it by remembering this one as formula. But there is a concept, very good concept is there to state the equation of circle quickly. If it has center hk and it is touching the x-axis, then its equation going to be x minus h whole square plus y minus k whole square equal to k square. This is the equation of circle which is touching x-axis at a point. Why? You know, equation of circle whose center is at x1 or y1. I just remind you again. And radius is r is given by x minus x1 whole square, y minus y1 whole square equal to r square. Then how do you take this as x minus h whole square, y minus k whole square equal to k square? Why k is coming in place of r? Because this thing going to be the radius of the circle. K is the radius of circle. That's why equation going to be x minus h whole square, y minus, because from center to x-axis, if you draw perpendicular, this has to be the radius. If there is a tangent to a circle, then it is quite obvious that the tangent will be intersecting the circle at one point only. And from center, if you draw perpendicular to the line, that length of perpendicular, center be C, length of perpendicular M. If CM is equal to radius, then the line has to be tangent. This has many applications in solving problem. This is another concept. If a line touches a circle, then from center to the line, length of perpendicular going to be equal to radius. So this thing, center to x-axis, if the center has coordinate h, k, then you all know this part is going to be h and this part going to be k. So k must be the radius because x-axis is the tangent. Center to x-axis distance is how much? All of you can see in diagram, it is k only. That's why equation is x minus h whole square y minus k whole square equal to k square. How to get the equation of circle when it touches the y-axis? It's like this. This time radius was equal to k. Radius was equal to k. But when you take the circle, it is touching the y-axis, then h is the length of radius. R is going to be equal to h this time, and the equation going to be x minus h whole square plus y minus k whole square equal to h square. We are using the same approach here. Now what will happen if a circle touches both the axes? So a circle touches both the axes if both are tangent. X-axis is a tangent at P, y-axis is a tangent at Q, then we can say that circle touching both the axes. What did you say in the previous problem? When it touches the y-axis, then h, the x coordinate going to be equal to radius. So this time if it happens, this going to be the radius, this going to be the radius. Circle has only one radius. If this part R, center has to be C, going to be R, R. Probably they have taken radius equal to h, so center, that's why they are getting h, h. After getting center h, h and radius equal to h, we can write the equation as x minus h whole square, y minus h whole square equal to h square. This is the required equation of circle. X minus h whole square plus y minus h whole square equal to h square. Okay? There is no different k. K and h, they are same. So remembering those three standard equations of circle, standard form of circle, and these few special cases, let us approach a few sums from circle. We are starting circle problems arbitrarily by taking this one as a problem. If one end of diameter of a circle is 8, 4, so that coordinate of the other end is minus 4, 2. Okay. So how to prove this? One end of diameter given, the other end has to be this. Can I use diametric form of the circle? You can use diametric form. But there is another easier method. This sum x square y square minus 4x minus 6y plus 11, we can start with its center and radius. You know, if the circle is x square y square 2gx 2fy plus c equal to 0, then minus g minus f is the center. So for this circle, on comparison with x square y square 2gx 2fy plus c equal to 0, what do you get? You get 2g equal to minus 4 and 2f equal to minus 6 and c equal to 11. So g minus 2, f minus 3 and c equal to 11. So center going to be what? Center going to be minus g minus f. Radius going to be what? Root 2. So if we know one end of diameter as minus 4 comma 2, the other end can be obtained quickly, easily. Because center coordinate we got minus g minus f, it means 2 comma 3. Center has coordinate 2 comma 3. The other end we don't know. Let the other end be h comma k. In the diagram, I am taking this point coordinate h comma k. So 2, 3 going to be the midpoint. Then h minus, by using midpoint formula, 2. So h is minus 8. Let us see why it is not matching. The 4 plus 4, this is going to be plus 8. So h comma k, center is 2 comma 3. Sorry, one end is 8, 4, it is given. The other end is minus 4, 2, we need to prove. So this is 8, 4. So we have to prove that hk going to be equal to minus 4. So 2 must be equal to h plus 8 by 2. This is minus 4 and 3 must be equal to. So k going to be 6 minus 4, that is equal to 2. So the extremity b is going to be h comma k, that is minus 4 comma 2. Alright. So if one extremity known, the other extremity can be determined. For this one, how to find center and radius? We will use the general equation of circle. The way we did previous one, we have compared, we found GF. From there, by using midpoint formula, we got the other extremity. How to get the center and radius for this circle? But the equation is 2x square 2y square minus x equal to 0. So first, whenever you get equation of this kind, you divide both sides by 2. So dividing by 2, what do you get? X square plus y square minus x by 2 equal to 0. So compare with x square plus y square, 2gx plus 2fy plus c equal to 0. 2g going to be what? Minus up, it is coefficient of x. 2f going to be what? This is 0. Here you get g equal to minus 1 by 4. And f is equal to 0. So center can be determined quickly, that is minus g minus f. So this is going to be 1 by 4 comma 0. And radius, how do you get? Radius formally you know, root over g square plus f square minus c. So r will be g square 1 by 16 g square plus f square. No f is there, 0, and this is also 0. So answer is 1 by 4. Radius is 1 by 4, center is 1 by 4 comma 0. Now there is a problem given here that if this line touches the circle, then what is the value of k? How to find, how to solve this problem? It's not coming from any standard equation of circle we have assumed. Okay, this is coming from the concept. What is the concept over there in number 4? If this line touches the circle, this, then find the value of k. What is the concept over there? The concept is, on the line, if you draw perpendicular from center, the length of perpendicular going to be equal to radius. If it happens, then the line y equal to root 3x plus k will touch this circle. All of you understand what I said? If a line touches a circle, then length of perpendicular from center to the line has to be equal to radius. So radius of this circle is what? The radius of this circle you all can see, it is x square plus y square equal to 4 square. So radius is equal to 4. the line which I have shown in the diagram, you may take y equal to root 3x plus k. For simplicity, you write this as root 3x minus y plus k equal to 0. Okay. Now, what is the center of this circle? Center is 0, 0. From center, if we draw a perpendicular, this must be equal to radius. The condition I told you. If a line touches a circle, then OM must be equal to radius. But O to M I can find easily by distance formula. What is length of OM? Use distance formula. 0, 0 to this line. K by under root 3 plus 1, that is K by 2. OM equal to K by 2. But they have given radius is equal to 4. So K by 2 and put a plus minus sign over there. This is compulsory for you. So plus minus K by 2 is going to be equal to 4. So R will be plus minus 8. Okay. So K equal to, sorry, not R. K is going to be plus minus 8. For these two values of K, the line will be tangent. If they have asked you to prove, show that this line touches the circle, you remember that thing, that center to the line length of perpendicular must be equal to radius. If it happens, then the line will touch the circle. And next, number 7. Find the equation of circle which is passing through the center of this circle and concentric with another circle. Unfortunately, that I forgot to take there when I was clipping. So, leave it. Wait a minute, just let us do this one. Find the equation of circle passes through origin, cuts off intercept 3 and 4 from positive x and y axis. Let's see what happens. Number 8. Find the equation of circle passing through the origin, so it is touching both the axes, it is cutting both the axes, isn't it? Passes through the origin, cuts off intercept 3 and 4. This OA is equal to 3 unit and this OB, OA equal to 3 given 3 units and OB equal to 4 units, it is given in the problem. And it is passing through origin. So just one common class 19 concept will help us to understand the sum. It is passing through origin and this angle is 90 degrees. So if we join these 2 points, don't you say that AOB 90 degree, so AB is going to be the diameter. AB is going to be the diameter. So your answer will be like this. It is quite obvious that AB is the diameter, where coordinate of the point A is 3, 0 and B is 0, 4. Okay. So writing equation will be easier in this case. It will be x minus 3 into x minus 0 plus y minus 0, y minus 4 equal to 0. Actually, this thing, that diameter form, will simplify the sum. That's why you have used. Some other method obviously there, that you take this center will lie here, draw perpendicular, easily you can get center and radius. From there you can do. Using Pythagoras theorem you can get radius. Center can be found here only. So you can solve problems of this kind. Now you will practice sums of this kind and we will be solving more sums in the next session on circle. Thank you.